Hi there, my name is Christopher Catis, and I work at the University of Utah on a U.S. Department of Energy funded research project called the Utah Frontier Observatory for Research in Geothermal Energy, or Utah Forge for short. Today, we are going to talk about geothermal energy, a clean, renewable energy source. So what is geothermal? Well, the word geothermal comes from two Greek words, geo or ye, which means earth, and thermos, which means hot. Geothermal is literally the heat that is beneath our feet, and the deeper you go into the earth, the hotter it is. In fact, the crust of the earth averages about 60 degrees Fahrenheit, but just below it, in the mantle, temperatures range between about 1800 and 6700 degrees. But that's nothing compared to the outer core, where temperatures reach upwards of 8100 degrees Fahrenheit. And in the inner core, the center of the Earth, you can find temperatures at about 9400 degrees. That heat can be turned into energy, and that energy is clean, which means it doesn't cause pollution. It also is renewable, which means it won't likely ever run out. You may have heard of other sources of renewable energy like solar or wind, and you may have even seen solar panels or windmills. Well, those are great sources of renewable clean energy, but solar only works when the sun is shining. And windmills need the wind to blow. Unlike solar and wind, geothermal is available 24 hours a day, 7 days a week, and in all weather conditions. So why don't we see it everywhere? Well, unlike solar and wind energy, which can be produced in many different areas, for the most part, geothermal energy can currently only be produced in places where natural geothermal systems exist. And these systems are found mostly in two areas, where the Earth's tectonic plates meet and where there are or were volcanoes. The heat from the Earth's core, or its center, can find its way to the surface in these places. So what does a natural geothermal system look like? Well, probably the most famous natural system in the world is in Yellowstone National Park in the western part of the United States. Its geothermal features include boiling mud pots, hot springs, and of course geysers, like Old Faithful. Today, they are protected as part of the world's oldest national park, so we can't use them for energy. But Native Americans who considered the area sacred used the geothermal waters in Yellowstone for cooking and ritual cleansing. In fact, humans have used the geothermal systems around them for at least 10,000 years. Middle Stone Age people used hot springs for warmth, cleaning, and cooking. Ancient Romans, Chinese, and Greeks used geothermal waters for therapeutic bathing. Ancient hot tubs, I guess. Today, that heat from the earth is used in many different ways, including for growing fish, flowers, and vegetables, and for spas, heating and cooling, and sometimes even to melt snow. Aquaculture is farming in water. People use geothermal waters to grow fish. In Colorado, it's even used to grow alligators. Greenhouses are kept nice and warm to grow flowers and plants all year round using geothermal heat. In the US, many of the poinsettias at Christmas time and the chrysanthemums around Memorial Day that we see in stores are grown in nurseries that use geothermal heat, like the greenhouse in the photos here near Newcastle, Utah. The heat in the earth can also be used to heat and cool homes and buildings. The University of Utah's Gardner Commons building uses the energy found just a few hundred feet below the earth to keep it warm in the winter and cool in the summer, saving the university $70,000 a year in energy bills. The city of Boise, Idaho has been using geothermal energy to heat some of its buildings since 1892. We can even use geothermal to make electricity in power plants. First, the water flows up the surface through a well and becomes steam. Next, the steam travels through a turbine to a cooling tower where it condenses and becomes water again. That change from steam back to water causes a drop in pressure, which then turns a turbine. The turbine is connected to a generator that makes electricity. Finally, the cooled water is then pumped back into the ground where the earth heats it up and the process starts all over again. Then why don't we use geothermal energy more often? Well, remember at the beginning of this presentation when I said natural geothermal systems are only found near volcanoes and where the Earth's tectonic plates meet? Well, in those places like Iceland, New Zealand, and Kenya, they do use geothermal. Over half the energy that people in Iceland use comes from geothermal. But in the United States, natural systems are not as common and are found mostly in the western states like California, Nevada, and Utah. But could it be possible we can still get geothermal energy in places where there isn't a natural system? Well, a natural system needs three components: heat, water, and a way for the water to travel so it can be pumped back up to the surface. We know that there's heat in the rocks. In fact, as we talked about earlier, the deeper down you go, the hotter the rock is. We can pump the water into that hot rock through wells we drill. So all we need is a way for that water to flow through the rock so it can be pumped back up to the surface. That's where enhanced geothermal systems, or EGS, come in. Let me explain. We drill a deep, deviated, or bent well. Then we inject cold water into the well, which opens up the tiny fractures or cracks in the rocks so the water can flow through the rock. A second deep deviated well is drilled so the hot water can be produced up to the surface to a power plant. And as we learned earlier, the water is injected back into the first well so the process can repeat over and over again. And why is it important that we be able to access geothermal energy almost anywhere? Well, scientists believe if we can get just 2% of the energy found between about 2 and 6 miles underground, we will have 2,000 times the energy used in the US every year. And all that energy is clean, renewable, and available 24 hours a day and 7 days a week. And that's good news for Mother Earth. Well, I hope you have a better understanding about geothermal energy and enhanced geothermal systems now. But we've just scratched the surface. To learn even more about geothermal energy and EGS, please visit the Utah Forge website. Thanks for spending a few minutes with me learning about the heat beneath our feet.